Okay. So yeah, so this is a number theory question. So we want to find the smallest number greater than 2 that leaves a remainder of 2 when divided by 3, 4, 5, or 6. And we are basically we want to know where does it lie? Like in which of the following intervals? And they gave us some intervals. So first, like um just not really like part of the problem solving, but the reason they probably asked about intervals rather than the actual numbers, like the reason they didn't like ask what is the smallest number that satisfies a condition, instead they asked like which interval does it lie in, probably because since this is a multiple choice question, if they were to give you the explicit number, like the exact number, then a lot of competitors would probably just go through the 5 answer choices and just test them all, and they don't want you to do that, so they gave you intervals instead. So we want to know the smallest number greater than 2 that leaves a remainder of 2 when divided by 3, 4, 5, 6. Okay, so this question kind of talks about like stuff relating to greatest common divisor and least common multiple. So basically, notice that like these numbers 3, 4, 5, 6, if a number is divisible by 4, or let's say like this, right? If a number is divisible by 6, it's going to be automatically divisible by 3, right? Because 6 is 2 times 3. So if a number is divisible by 6, it means it's divisible by 2 and 3. So we don't really have to worry about this like 3 thing here. Like if a number is divisible by 6, it's automatically divisible by 3. So we can just kind of disregard the 3 there. So notice that like let's first ignore the 5. Like let's pretend the 5 doesn't exist, right? So let's take a look at this 4 and the 6. So what's the smallest number that's divisible by 4 and 6? So let's first write down the number 6, right? Let's see, is 6 divisible by 4? Well, clearly not. 6 is not divisible by 4. So let's move on to the next highest multiple of 6, which is 12. Now let's see, is 12 divisible by 6? Well, yes, 12 is divisible by 6 because this is the second multiple of 6. Is 12 divisible by 4? Yes, it is divisible by 4, right? 12 divided by 4 is an integer. So 4 and 6, kind of like, this is what we call the least common multiple, is going to be 12. Like 12 is the smallest number that has both 4 and 6 as its divisors. So now now we can kind of forget about the 4 and forget about the 6 and just focus on the 12 and the 5. Like let's bring in the 5 back in because we can't ignore it forever. So now let's take a look at the numbers 12 and 5. So what's the smallest positive integer that is divisible by both 12 and 5? Well, one way to do it is you can just list out all the multiples of 12. So like 12, 24, 36, 48, 60, 72, so on. These are the multiples of 12. And we can go one by one to check which ones are divisible by 5. So is 12 divisible by 5? No. Is 24 divisible by 5? No. Is 36 divisible by 5? No. How about 48? Is 48 divisible by 5? No. Then we move on to 60. Is 60 divisible by 5? We see it is, right? 60 is divisible by 5. So that tells us 60 is the smallest positive integer divisible by both 12 and 5. So that tells us 60 is the smallest positive integer divisible by 2, or not 2. Yeah, I mean, yes, 2, but like divisible by 3, 4, 5, and 6, which is what we wanted. Again, this, like, we should read the problem, I guess, carefully, because you can't just say, oh, we see 60 is the smallest positive integer, so we see choice C contains the interval like 56 to 60, right? So you might pick choice C and move on. But remember, like, the problem writers are not always very nice people, so they'll probably like try to trick you in some way. So like the question asked about like remainder, like it says when the number is divided by these numbers, it leaves a remainder of 2. But that's like a pretty easy fix, right? Because we can just do 60 and we just add 2 and we get 62. So that, like, we just take this number 60 that's divisible by 3, 4, 5, and 6. So by just adding 2, that just forces all all of these numbers to leave a remainder of 2, or it just forces 60 to leave a remainder, or 62 to leave a remainder of 2 when divided by the numbers 3, 4, 5, 6. And just to just verify that the number 62 works, right? If we do 62, we were to do the division by 3, we would get 20 with a remainder of 2, which is, we have this 2, so we're happy. If you were to do 62 divided by 4, you would have 15 with a remainder of 2, which is also normal. If you do 62 divided by 5, you get 12 with a remainder of 2, which is right. And if you do 62 divided by 6, you get 10 with a remainder of 2, which is also right. So that would tell us 62 is the smallest positive integer that satisfies these restrictions. So that would give us choice D, right? Because 62 is between 61 and 65, and we would be done.